Hello, class. Today we're going to be talking about functions versus relations. Um, you should have some guided notes to help you keep these notes organized so that you can kind of stay focused on what's going on and pay attention to the examples. Let's go first by defining relation. A relation is any set of input that has an output. And as you can see on your guided notes, there are some blanks on your guided notes. You just need to fill those in, but make sure you pay attention to what's going on as we go through this. A function is a relation where each input has exactly one output, or each element from the domain is paired with one and only one element from the range. We'll talk about some examples of that here in a little bit, but that is a basic definition of a function. And now to define domain, to make sure we understand that, it's your x coordinates, your independent variable, or your input. Now we're very familiar with x coordinates and input, hopefully. But your independent variable, it means that it's the variable that does not change based on something else happening. So a good example would be if you talk about how much you get, the number of hours you work to how much you're going to totally get paid. So the number of hours you work is completely independent of everything else. No matter how much you get paid, you're going to work the hours that you work. The total amount that you get paid is going to depend on everything else would bring us to range, which is your y coordinates, your dependent variable, and your output. So if we're talking about the hours you work to the total amount you get paid, the number of hours you work is your independent variable, and the total amount you get paid is your dependent variable, because how much you get paid will depend on how many hours you work. Now, how do I know it's a function? So we should be able to look at a input or output table, and each input must have exactly one output. And I know that may sound a little confusing, but we're going to do some examples to help you understand that a little bit better. Then when you're looking at the graph, some of you may remember doing the vertical line test. No vertical line can pass through two or more points on the graph. Now remember, a vertical line is the one that goes straight up and down. So we're going to see an example of that on the on this PowerPoint as well. Now, if we have if we're looking at this example right here and trying to determine if it's a function relation, I don't have an input and output table, but I can look in here and see which one are my x values and which one are my y values. So my x's are 3, 4, 5, and 6. So those are my x values. And because my x values do not repeat at all, my x values only have one, my input only has one output. So therefore, it is a function. Now, on this one, I have something that looks more like a table, but I have, again, -3, -2, -1, 0, 1, 2, 3. I do not have an x value repeating, and if I look at the lines, there's only one line coming from each of those. It doesn't matter where they're going, just because there's only one line coming from it, it means that each input only has one output. So again, that is a function as well. Now if we look at this one, we have 1, 2, and 3 as my input, so they don't repeat, but something is a little different on this one than the last one. If you look at 1 on my input right here, it has 2 arrows going from it. So this input is going to -1 and going to -3. So this input has more than one output, therefore it is a relation. All right, if I was to look at this function, if I have students' names as my x value and shirt color as my y value, well, the students' names are Vincent, Kara, and Roman. They do not repeat. So because their names do not repeat and each of them only have on one color shirt, it is a function. All right, so now if I'm looking at a graph, the graph is the red line, the red thing right here. That's our graph. The green line right here is our vertical line test. So as we look, if this was my vertical line, and the way I would do the vertical line test, I would take this green line and I would slide it all the way through to see if there's anywhere that I could have that vertical line that it would touch 2 points on the graph. And as you can see right here, I touch that red graph right here, and I touch it right here. So because of that, the vertical line touches more than 1 point on the graph, therefore it is a relation. All right, if I look here on this example, even though I have 3 people going to Honda and 2 people going to Toyota, or that have Toyotas and have Hondas, it is still a function because each person only has one output. Each of these inputs only has one output. So it doesn't matter if everybody over here had a Honda, it would still be a function because each person only has one type of vehicle, the Honda. All right, so if I look at this one, a person's cell phone number versus their name. Well, if they have a cell phone number, if that's their input, what do we know about cell phone numbers? There's no 2 cell phone numbers that are alike. So all cell phone numbers are unique. So it would be a function because it only has one output. Now, I know some of you may be thinking, well, it could be a relation. I can maybe buy into it, but you have to give me a reason why. So if you can think of a reason why this example could be a relation, tell me. Now we're going to start talking about function notation. So we've learned what a function is and how it operates. Now we're going to talk about function notation, which is, by definition, a way to name a function. F of x is a fancy way of writing y in an equation. So basically, we can take out, if we had y equals mx plus b, we could take out the y and put f of x, and now it's a function versus an equation. And it is pronounced f of x, so that we understand the proper way to say it. And now we're going to talk about evaluating functions. So evaluate functions, basically what it's saying is when I have a function and we have the function and it tells us that x is equal to a number. So what we have to understand is when x is equal to -2, what we're supposed to do with that is plug the -2 in everywhere that it goes. And when we write the -2 right here in the highlighted area, you need to understand that says, what is your answer when you plug -2 in? Okay, so that would also be another way to write the question. So we plug -2 in, we do the math. 2 times -2 is -4, minus 3, and then you get -7. So f of -2 equals -7 is the proper way to write the answer. And again, that is another way to write, even though it says f of -2 right there, it's another way to write y. So it's still saying y, but it's saying this is my answer to y when I plug -2 in for x. All right, so right here, it's asking you to evaluate when x is 3, okay? Try to pause the video and solve the problem yourself, and then watch the answer being worked out. Okay, another example, try this one when f of, and this one it says find f of -3. So we've been, on the other 2 problems, it asked you to find, it told you x is equal to whatever. This time, sorry about that, but this time it's saying that you have f of -3, which again means to plug in -3 or find the answer when x is 3, -3, I mean. So you plug in -3 everywhere there's an x, including right here in the function notation. And and again, it tells you what you get when x is -3. And you start -3 squared. Got to remember, it's +9. -2 times -3 is 6, +6, and then +3, and then you add all those together and you get 18. All right, so this time we're going to start talking about domain and range real quick. You only list the repeats once, put in order from least to greatest. So if we're looking at this, our domain is, again, our x values or our inputs. So we would list all of the numbers that we have in our domain, and then we would list all of the numbers we have in our range. That is how simple domain and range can be when we're looking at functions. And now if we look at this graph, to find your x values, you look at each of those points and you find the x value of the points. And that would be your domain. So your domain is the 0, 1, 2, 3, and 4. And you look at those same points, and now to find the range, you pick the y values that those points are on. And so that's how you get 1, 2, 4, 8, and 16. All right. Now, if you notice on this one, the points are not connected. Now, when we have one like this where the points are connected, and we have an arrow at the end of the line, now that changes things. Because does that line ever end? No, it doesn't end because you have arrows on both sides. So now our domain is a little bit different because everywhere that line is, that's part of our domain. And our line never ends, so our domain never ends. So the first way we're going to learn how to say that is all reals. Every x value you can possibly think of is part of this graph. And just like the domain, our range is our y values going up and down. So again, there's arrows, and that arrow is, if I'm looking at from the perspective of going up and down, it's going to keep going. So that is also going to be all reals. Now, let's look at one last example, and then we'll be done with the notes. This graph is a little similar to the last one we just looked at, but a little bit different. If I look at the x values, where does my domain, I guess, start? Especially since I'm going to be looking, I guess, left to right. Can I say all reals again because there's two arrows? For my domain or my x values, I can't do that. So what we are going to say is every part of my domain is greater than or equal to -1. So that's one way to write that fact. And we're going to learn other ways later on. But if you look at -1 on the x-axis, every part of that graph is greater than that point. So x is greater than -1. Now for my range, however, I'm looking at the y values. Those arrows are pointing up and down still. As far as that goes, it's going to be every y value you can think of as part of this graph, both positive and negative. So again, you would have all reals there. So thank you. Make sure that you have your notes for this.